In this problem, we're dealing with an equation involving rational expressions. So just like when we were dealing with addition and subtraction and complex fractions, first thing we need to do is find our LCD. So we want to factor all denominators, but none of them can be factored. So from the first denominator, we know we need a factor of x. Looking at the second denominator, we need a factor of x plus 8. And the last denominator is also x plus 8, but that's already there. Now, when we dealt with addition and subtraction, we had to multiply the numerator and denominator by what was missing. And we wound up rewriting each expression with the LCD as the denominator. That's not what we're going to do here. So let me rewrite this and leave a little more space here. And what we're going to do is multiply each term by that LCD. Every term, whether it involves a fraction or not. So x times x plus 8. And I'm going to put it over 1 since I'm multiplying by a fraction. X times x plus 8. And again, we're multiplying by a fraction, so we'll put it over 1. And now we're going to cancel common factors. So in this first term, we have x, and we are left with x plus 8 times 1. When we have a minus here, be very careful, but we have a plus, so we don't have to worry about it. And we're going to cancel the x plus 8s, and we're left with x times 1 over 1. And in this last term, we can cancel the x plus 8s, and I should have put parentheses here. So we're left with x times x plus 9, so that's x squared plus 9x. Let's do a little cleanup because on the left we have some like terms. X plus x is not x squared, it's 2x plus 8 equals x squared plus 9x. Now, if your LCD was correct in this step here, you should have been able to cancel all the denominators and you should have wound up with an equation with no more fractions involved. Now you have to evaluate the type of equation you have. When we see x squared here, we know that we have a quadratic equation, and the only way we know how to solve those at this point is to get 0 on one side. So let's subtract 2x and 8 from both sides. That'll give us 0 on the left. Of course, we have to do the same on the right side. That leaves us with x squared plus 7x minus 8. And now we're going to factor. Trinomial, leading coefficient is 1. Last term is negative. Factors of 8 whose difference is 7. Well, 8 times 1 is 8, and the difference is 7, so the larger factor gets this middle sign. And now we're ready to set each factor equal to 0, so x plus 8 equals 0, and x minus 1 equals 0. Make certain you do solve and you don't stop there. Subtracting 8 from both sides, we get x equals negative 8. And adding 1 to both sides, we get x equals 1. You are not done. When you solve an equation involving variables in the denominators, you have to make certain that those solutions are acceptable. So if I put negative 8 here, would I get 0? No. If I put negative 8 here, would I get 0? Yes, I would. So x cannot equal negative 8. What about 1? If we put 1 in this first denominator, we would not get 0. If we put 1 in this second denominator, again, we do not get 0. And same with this third one. So 1 is acceptable. So the only solution here is 1. What I'd like to do now is look at this problem and see what happens if you attempt the same method that you would have used if you were adding and subtracting. So suppose instead of multiplying every term by the LCD, instead I multiplied numerator and denominator by what was missing. So here we would be multiplying by x plus 8 over x plus 8. Here we'd be multiplying by x over x. And here we'd be multiplying by x over x. So this is the format we used when we were adding and subtracting, right? We multiplied by what was missing. So we wind up in this first term with x plus 8 over x times x plus 8. In the second term, we wind up with x over x times x plus 8. And in this last term, we get x squared plus 9x over x times x plus 8. Now, I want to be clear on the graded homework. Don't use this method. I was very clear about what I wanted. But on an exam, if you did go this route, that you can still deal with it. So now you add these two expressions, and x plus 8 plus x, well, we get 2x plus 8 over x times x plus 8 equals x squared plus 9x over x times x plus 8. Now here's what happens. Students do this because they knew this procedure, and then they get here and they don't know what to do. Well, just as a side note real quick, if I had x over 5 equals 3 over 5, guess what? Since the denominators are equal, the numerators have to be equal also, which means that x has to equal 3. Let's apply that to what we have here. Our denominators are equal. Therefore, those numerators must be equal as well. So let me clean up a little here. So we said the numerators have to be equal, so 2x plus 8 equals x squared plus 9x. And if you go back and look at what you wrote before, this is exactly where we wound up before. So the other way is a little less work, but this way is doable. So let's go to the next problem.